So far in this chapter, we haven't spent any time talking about word problems related to systems. I prefer to learn all of our different methods first for solving systems, and then now that we've kind of had that under our belt, we can tackle some more challenging examples. The unfortunate thing about word problems, especially when it comes to taking notes, is that you guys do have to write down the problem, and it's kind of annoying that you have to copy this down. I apologize for that. I know that I find that word problems are something best covered in class, so we'll do tons of examples in class, and you'll get some more practice with them. But in this video, I have two problems just to give you guys a frame of reference for where to start. Please do write these two problems down. I tried to keep them as short as possible. Feel free to abbreviate on them if you need to. But let's go ahead and tackle this first example here. So in our problem, it's talking about the price of hot dogs, the price of hamburgers, and we want to know how many of each they sell. The first thing you need to do in a problem is decide what you don't know. And whatever that is, you're going to give it a variable. So there are actually two things we don't know in this problem that they're looking for. We want to know how many hot dogs, and we want to know how many hamburgers. Since there are two things we don't know, we're going to have two variables, x and y. Typically what I'll do is I'll write down my variables that I'm going to use, and I'm going to write what they mean in the problem. So the first thing they mention, typically I just make x the first thing I come across in the problem, is the hot dogs. Specifically, x is going to be the number of hot dogs. A lot of kids will just abbreviate here and put the word hot dog or something like that. It is kind of helpful to have the number part in there, because otherwise if it just said hot dogs, you don't know, is that the price of the hot dogs, is that the weight of the hot dogs? It's just best to be specific. Y is going to be the number of hamburgers. So, since we have two variables in this problem that we don't know x or we don't know y, we need a system. If you have two variables, you will need two equations to be able to do the problem. If we had three variables, we would need three equations. So we need to take the information in our problem and turn it into two equations based on what it says. The first thing that I noticed in the problem here that I might kind of take and put into an equation is that they sold 57 items altogether. So 57 items were sold. X is how many hot dogs, Y is how many hamburgers. If you add up the number of hot dogs and the number of hamburgers, you're going to get 57, because that's how many items they sold. So my first equation here is going to be x plus y equals 57. So, with that being taken care of, we still need to make another equation out of our problem. And the other piece of information we haven't used yet is dealing with the prices. Hot dogs are $2.50 a piece, hamburgers are $4 a piece. They made this much money altogether. So $2.50 per hot dog plus $4 per hamburger equals $166.50. So that is my second equation there. If you multiply the number of hot dogs by 250, number of hamburgers by 4, you get that total price. Now, those two equations right there are ready to be solved. You can do what you're going to do with them, whichever of our four methods you like. Now, my personal opinion here is that I just did a lot of work making equations and figure out what was going on. I don't really want to sit there and do elimination on this, or get y by itself and do substitution, or graph them. Those are all kind of a lot of work. So what I would much prefer to do is just use the new calculator method, use the matrices. Once you have the equations, you don't want to sit there and do a bunch of extra work, just pop it in your calculator. And if you go through the whole process that I covered in the last video, this is what my calculator ends up saying after I typed it in. And as you recall, the top number is x and the bottom number is y. So it looks like I sold 41 hot dogs and 16 hamburgers. So 41 was x, that's going to be 41 hot dogs and 16 hamburgers. If you would have solved that by hand, elimination or something, you'd get the same answer, but that is what we end up with for our first problem. One more word problem for this video. Again, you're going to want to pause the video and write this down. But we're dealing with a situation where we have a store selling bicycles, tricycles, and cars. So, they ask us in the problem, how many cars are there? Cars are going to be one of our three variables, but there are three things we don't know. Even though we didn't specifically ask for it, we don't know how many bikes, we don't know how many trikes, we don't know how many cars. So I'm going to have three variables in this one. X can be the number of bikes, y can be the number of tricycles, and z can be the number of cars. And the way that this is organized here, the way I made my variables, I just took it in the order they said them. Bikes was first, so it's x, then trikes, then cars, so x, y, z. So we have our three variables right now. If we have three variables, we need three equations. So based on what's in this problem, there need to be three equations we can make. First thing I see is that there are 25 items in all. That means if you add up the bikes, the tricycles, the cars, you're going to get 25. So x plus y plus z is going to equal 25. So that's one equation down. Now, there are two pieces of information that we still haven't used. There are a total of 62 wheels between all of our different objects here. Remember, every bike has 2 wheels, so if you have 3 bikes, you would do 2 times 3 for the number of wheels. Every tricycle has 3 wheels, so we'll do 3 times the number of tricycles. And every car has 4 wheels, so I'll do 4z for that one. And altogether, I have 62 wheels. So that's going to be my second equation. I need to come up with one more equation in my problem. And the piece of information I didn't use yet is this part right here. There are 7 more bicycles than tricycles. So 7 more means that one of our 2 variables is going to get a plus 7. 7 more, you're adding 7. So my bicycles and my tricycles are x and y. The question becomes, which variable gets the plus 7? And this is something that kids do mess up with. It's easier to show in person, so I'll probably do this in class. I'll try to show it on the video too. Picture we have some bikes and we have some tricycles right here. You want to know which one gets the plus 7. So you have to ask yourself first off, are there more bicycles or are there more tricycles? And if there are 7 more bicycles, there's already more bikes. So bikes are up here, tricycles are kind of down here. If you do a plus 7 on the bike, so you do x plus 7, which is what a lot of people think to do, you're taking the bigger guy, the bikes, and you're making it even bigger. So you're making the difference bigger. You don't want to do that. What you want to do is add a plus 7 to the smaller guy over here, the tricycles, so that way they're even. So you take the smaller one and you add 7. So what I actually want here is x equals y plus 7. If you add 7 to the tricycles, it's the same as the bikes. So you would reorganize this, subtract it if you want to do the matrix approach, which you would pretty much have to on this problem. I haven't shown you how to do these by hand. Subtract the y, you put in a 0 for z and all that good stuff. I'm not going to show all the steps here because I think hopefully you guys are starting to get the hang of it. The calculator tells me though, when I finish my problem, this answer right here. This is what the calculator will spit out. So you have to make sure you answer the question they wanted. They asked for how many cars. There's x for bicycles, tricycles, cars are right here. There are going to be 2 cars.